Hello, everyone, and welcome to the Physics 121 concept session on applying multiple kinematic equations. My name is Nathan Martin, and I work for the tutoring centers at ASU. So, in this problem, we're given a car is traveling at 15 meters per second. It slows down at a constant acceleration until it stops. During its slowing down phase, it travels 100 meters. What is the acceleration and how long did it take to stop? Okay, so this problem, we're going to need to use at least two kinematic equations, and you'll see why very shortly, kind of why this is the case. Okay, so I'm just going to kind of start out with the, I guess, most basic kinematic equation, right? So your final velocity is equal to the initial velocity plus the acceleration times time. Okay, so now whenever I do these kinematic, whenever I'm doing problems that deal with these kinematic equations, I like to kind of make a little list of what I know and what I don't know. Okay, so let's just kind of start that list. So the final velocity. Do I know this final velocity? Yes, I do. Right, because we're finding when it stops, right? So if it stops, that means my final velocity has to be 0, right? So my final velocity, 0 meters per second. Do I know my initial velocity? Yes, that's given to me. 15. It's 15 meters per second. Do I know the acceleration? No, I don't. Do I know the time? No, I don't. That's what I'm trying to find, right? I'm trying to find the acceleration, trying to find the time. So I have one equation with two unknowns, right? This is one equation with two unknowns. Therefore, I cannot solve that system. This system is open, and in order for me to solve it, I have to close it, right? So what that means is I have to have two equations. I have to have two equations with two unknowns to solve, okay? So I want this. This is bad. I can't solve that, right? Well, what else do I have? Well, we have another kinematic equation, right? Do you remember this one? V squared, so the final velocity squared, is equal to the initial velocity squared plus 2 times the acceleration times the change in distance, right, delta x. So in this one, do we know the final velocity? Yes, it's already in our little kind of table over here, right? We know it's 0. Do we know the initial? Yeah, it's in our table, 15. Do we know the acceleration? No. Do we know that delta x? Right? Do we know delta x? Yes, we do, because it travels, right? It travels 100 meters. So if it travels, right, it's 100 meters. Cool. So see how we now have closed this system? We now have two equations with two unknowns. So what I'm going to do is solve for time, okay? I'm going to solve for time first. So in order to do that, I'm essentially going to solve for a in one of these expressions, okay? So I'm going to look at the v, f squared, all that. So 2a delta x is equal to, that would equal the final velocity squared minus the initial velocity squared, right? If I solve for a, I will divide by 2 delta x. So vf squared minus v naught squared is equal to 2 delta x. I can solve that outright, right? I know what the final velocity is. It's 15 squared. I know what the initial velocity is. That's 0. And I know what the x is. So the acceleration is just equal to, what is that equal to? 15, hold up, I messed that up, right? It's, my final velocity isn't 15. My final velocity is, it's 0, right? So I had these flipped. So my velocity is 0. My initial velocity was 15. So this acceleration, if you were to compute that in your calculator, you find that it is -9/8. So -9/8 is about -1.125 meters per second squared. So that's the acceleration. I want, before we move on to the time, I want to point out, why is that negative? So that acceleration is negative because it's slowing down, right? If it's slowing down, you would have to be negative, right? Cool. So now let's look at the time. Wait, I said we were solving for time in that other one. Oops. We'll look at the time now, okay? So, solving for time. Let's look at the VF plus V naught, not plus. This is kind of a struggle, you guys. It's VF is equal to V naught plus the acceleration times time. So, I want to solve for time, right? Because I know VF, I know V naught, and now I know A. So if I solve for time, time would equal VF minus V naught all over A. T, the V naught is 0. So 0 minus 15 over A minus 1.125. Throwing that into my calculator, I find that the time is equal to about, I'm going to approximate it. It's equal to 40/3, but I'm just going to throw that in a decimal. So that's about 13.3 seconds. And again, that's positive, right? Because time is positive. Notice how we had a negative in the numerator divided by a negative acceleration. Thus, the negatives canceled. And now we have a positive time. So cool. That's how you solve kinematic, or that's how you solve a problem with multiple applications of the kinematic equations. A thing to note, whenever you do these, I highly recommend solving it in terms of letters first. See how I solved for A and I solved for T in terms of letters first. It makes your life so much easier. So I highly recommend that. And then I also highly, highly, highly recommend making this table of knowns and unknowns so that you can wisely pick your, correct kinematic equations. If I picked, say, a different one, maybe it wouldn't have worked, right? But with that being said, good stuff, right? So let's clear that up and talk about our tutoring services, right? So if you want to learn more about all the tutoring services we offer, such as hours of operation, any review sessions we hold, additional content and whatnot, visit our website at tutoring.asu.edu. And then if you want to view more of these recordings and whatnot, go to this link down here, tutoring.asu.edu/student-services/reviews. Thank you all for listening to this, and we'll see you in the next video.